Hey there, my name is Michael Prinsing, and I am a postdoctoral research associate in the Psychology and Neuroscience Department at Baylor University. This video is a brief introduction to the methods of psychological science. It's kind of like a 30,000 foot overview of some of the basic concepts and ideas that are central to research in psychology. So, starting off at a very broad level, what is science? What makes something scientific? Obviously, this is a vexing problem in the philosophy of science, and I'm not going to resolve that question here, but it sure seems like one of the most central things to science is measurement. Right? Scientists run studies. They go out and they collect data. That is, they measure things, and they analyze those data in order to draw conclusions. But what the heck is measurement anyways, right? I mean, measurement comes in many, many different forms. So within psychology, what does that even look like? Well, I'm going to lean heavily on this definition of measurement that comes from a 1946 paper by Stanley Stevens. He defines measurement as the assignment of numerals to objects or events according to rules. This has been a very influential definition. My paraphrase of it is the principled application of numbers to phenomena, right? So there's something out there in the world that we want to measure, and we have some principled basis for saying, here is a number that represents that thing that I'm measuring. In psychology, usually what that involves is having some kind of procedure or operation that generates a numeric value to represent a mental phenomenon. So if you've heard the phrase or the term operationalizing, that's what that's a reference to, right? So you have this definition or some concept in mind. You say, I want to measure anxiety, or I want to measure love, or whatever it is. You need to somehow turn the definition of anxiety or love into a procedure or an operation that you can use to generate a numeric value. That's what operationalizing means, right? And then psychologists often use this term construct to refer to the mental phenomenon that they're trying to measure. Construct is a weird word. It almost sounds pejorative. My background originally was actually in philosophy, so when I came to psychology, I just felt like this is such a strange term. And so examples of constructs could include anxiety, like I mentioned, love, generosity. It's basically anything that a psychologist would try to measure. It's anything that would appear in a psychological theory. But why is it called a construct? Why is that the word? I think to understand that, we actually have to do a very brief detour into the history of this term, and indeed the history of psychology as a field. In the very early days, there were people like William James and Freud who were theorizing about the mind, thinking about how the human mind works, but their evidence base was their own introspection, their conversations with friends or other people, things that they had read. It was very anecdotal. It was very, well, not that scientific, right? So when people started wanting to get rigorous and start, measuring things and doing, psychological science, there was this thought that, well, to measure things, you need to assign a number to something you can observe. But how do you observe a mental phenomenon? How do you observe love or generosity? Well, you can't smell it or taste it or touch it. It's in somebody's head, right? So what do? Well, there was this thought for a while that you just can't. You just can't directly observe any psychological phenomena. But what you can directly observe is behavior. So there's this whole movement for a long time called behaviorism, which said, don't talk about the mind. If you want to do science, you can't talk about mental phenomena because you can't directly observe them. All you can talk about is behavior. For a variety of reasons, that movement completely imploded and was superseded by, movements that came afterwards. But even afterwards, I think there was a bit of caginess or hesitation or kind of discomfort that a lot of psychological researchers had with the idea of talking about mental phenomena as something that you could study scientifically. So that pejorative flavor to the word construct, I think, is real. Like it really was that people felt a little weird about it, but they're like, we want to study love. We want to study, anxiety or generosity and these things that are truly in the mind and not behavior. And so they had to be they were feeling a little awkward about it, right? So the basic idea is actually that the construct is not directly observable. The construct is this thing that you don't directly see or taste or touch, but nevertheless you can make reasonable, justified inferences about it on the basis of things that you can observe, including behavior. Just to ground this in an example, suppose you turn to somebody and you notice that she's biting her nails. Then you notice a little bit later, when she reaches for her water glass, there's a little bit of a tremble in her hand. When she speaks, there's a little bit of a flutter in her voice, and you start to think, wait a minute. These three things, they're not coincidental. They're all manifestations or reflections of anxiety. There's something in her mind, anxiety, that is giving rise to these three observable behaviors. Right. You didn't directly see anxiety. What you saw was nail biting, trembling, and you heard the vocal flutter. But it would be very weird to think that that was not a good reason for thinking this person is anxious, right? So anxiety is the construct. It's not directly observed, but it is indirectly observed through these observable indicators. These three behaviors that we did observe are indicating, are manifesting an underlying psychological state, right? So if we want to measure anxiety, what do? Well, one approach would be to say, okay, we're going to come up with a set of rules, a principled procedure, operation for converting these observable things into a number where that number will represent the underlying mental phenomenon. So just in this kind of toy example, if the person's biting their nails, maybe the rule is you get 1 point. If they're trembling a little bit, they get 1 point. Or if they're trembling a lot, then they get 2. Same with vocal flutter. So then what we end up with is a scale that ranges from 0 to 5 for anxiety, right? We can assign a number, and that number is our attempt to represent anxiety, something we didn't directly observe, but something that we can make inferences about. So this is just a toy example. This is not a real measure from psychology. Maybe it's not even a great set of rules for coming up with a number to represent anxiety. Here is a real one. This is called the GAD-7, the Generalized Anxiety Disorder 7-item scale. You present participants in a study with these instructions. You say, over the last 2 weeks, how often have you been bothered with the following problems? And then they report for each of the 7 things, not at all, maybe several days, more than half the time, like every day. Then what we do as the researchers is we say, okay, each one of those responses gets a number. If it's not at all, it's 0. If it's nearly every day, it's 3. Then each one of these questions is now an observable indicator. We can average across them, and now we have a scale that ranges from 0 to 3 that represents a person's anxiety. Right? And that number might vary from day to day for a given person. It's going to vary between people, right? And now what we have is a variable, right? Now we can do statistics. Obviously, we're not going to go into depth on statistics in this short video, but just to give you a sense of some of the terminology that people use here, we often talk about independent variables and dependent variables. A dependent variable is a variable that depends on some other set of variables, which we call independent, just for the contrast. One thing that's really frustrating about statistics is everything has about 5 different names. So sometimes independent variables will be called predictors, and dependent variables will be called outcomes. Sometimes dependent variables are called criterion variables. There's a million different names, but these are the most common ones. Often we represent relationships between variables using arrows. So in this case, it would mean the independent variable is predicting or causing the dependent variable, right? But if there's some relationship between these two, x and y, you might think that the relationship is immediate and direct, but it's also possible that the relationship is somehow mediated. There's some indirect process that goes between the independent variable and the dependent variable. So you can think of mediators as mechanisms, right? If people talk about something mediating a relationship, what they're saying is that the relationship is not purely sort of like one billiard ball hits another. The causal relationship is like that direct. Rather, there is some kind of process that the independent variable kicks off that goes through the mediator. The process involves some kind of mechanism that leads to a change in the dependent variable. So just as an example, sticking with our anxiety kind of stuff, the dependent variable might be anxiety. We have some measure of that. The independent variable, let's say, is some kind of social situation. Say we put you in a situation where we say, in a few minutes, we're going to have somebody come in and assess your work. Maybe that makes you feel a little bit anxious, right? The mechanism, the mediator, is whatever it is that's going on in your mind that leads to the anxiety as a result of being in that social situation. So I don't know, maybe when somebody tells you somebody's going to come in and assess your work, that starts off a process of thinking about times in the past when you've been criticized. How did that feel? You're thinking about past stress or discomfort, or maybe you're thinking about ways in which you failed in the past, or things that are weaknesses for you. Thinking about these negative things then maybe leads to anxiety. So maybe that's the mechanism, right? Another thing that we often talk about when we're trying to understand relationships between variables is moderation. And often moderation is represented with an arrow pointing at another arrow, because the idea is that the relationship between the independent and dependent variable depends on the moderator. So anytime you want to say, what's the relationship between X and Y? If the answer is, it depends, then that's a claim about moderation. That X predicts Y, but only, say, for men and not for women. Or maybe X predicts Y, but more so for people who are, confident in themselves or something like that. So sticking with the example we had before, you're in a situation where somebody says you're about to be assessed, your performance is going to be evaluated. That's the independent variable, whether or not you're in that situation. The dependent variable is anxiety. But you might think that that situation is going to elicit anxiety for some people more than others. Maybe people who are very high in self-esteem are going to have less anxiety in that situation than people who are lower in self-esteem, right? That's to say, what is the relationship between being in this situation and anxiety? It depends. It depends on self-esteem. So self-esteem moderates that relationship. Now that we've got our feet on the ground in terms of what it means to measure things, and then once we've measured some things, how do we think about the relationships among the phenomena that we're measuring? How do we analyze the data that we get from those measures? Now let's think a little bit about what it means to do these things well. In this paper that I quoted before from Stanley Stevens, there's this really wonderful line at the end where he says, measurement is never better than the empirical operations by which it's carried out. And operations range from bad to good. So any particular scale may be objected to on grounds of bias, low precision, restricted generality, and other factors. But the objector should always remember that these are relative and practical matters, and that no scale used by mortals is perfectly free of their taint. Since the idea is measurement is about using rules to apply numbers to phenomena, well, those rules can be good or bad. They might make sense in certain contexts. They might not make sense in other contexts. They might be appropriate for measuring something at very low levels of that thing, but not at very high levels of that thing. There are all kinds of ways in which things can go wrong. And the point he's trying to make is that measurement error is going to be with us no matter what. Our job is to try and reduce that error, to minimize it as much as we can. Now, there are at least two ways in which a procedure or set of rules for generating a number, i.e. measuring something, can be good or bad, right? One way of being bad is by not actually measuring the thing that we wanted to measure, right? Just measuring something else. Another way of being bad is by not measuring something consistently. This image is a very common one when people talk about validity and reliability of measures, which is those two things. Validity is, are you measuring the right thing? Reliability is, are you doing something consistently? Right. So on the far right, we've got a measure that's both valid and reliable, the metaphor of hitting the bullseye consistently, right? Like, to be valid is to be focused on the bullseye. To be reliable is to have a really tight grouping such that you're very consistently hitting something, and that something is the right thing, the thing you're trying to hit, right? As opposed to just to the left. So the third circle would be a case where you are valid, meaning you're focused on the bullseye. The center of the grouping is centered on the center of the target, but the grouping is really big. You're not consistent, right? The opposite would be when you're reliable but not valid, you've got a very tight grouping, but it's just focused on the wrong point on the target, right? How do we assess these things? So suppose we have a measure. How do we know if it's valid? How do we know if it's reliable? Well, one way people often think about this is in terms of face validity. This one I think is actually a little underappreciated. It just means literally on its face, does this seem like the sort of thing that could measure the phenomenon we care about, right? So if you look at the items on a self-report measure and you're just like, this just doesn't seem like the thing that they were talking about in the introduction, that might be a concern about face validity. Construct validity is a much more statistical notion. It's about the relationships that a measure shows with other measures, other variables. So the idea is we start off with some kind of background theory of the thing we're trying to measure, say anxiety or something like that. If our background theory of anxiety were true, then what kinds of relationships would we expect to see between a measure of anxiety and then other things, right? So maybe anxiety and depression should be related according to the theory, in which case if we have a new measure of anxiety and we want to validate that measure, one of the things we might do is say, okay, is it associated with measures of depression? If not, it might be a problem for the anxiety measure. Content validity is kind of related to that, and it's the question of whether or not the measure seems to assess all of the features that appear in the theoretical definition of the construct, right? So again, we start with some idea, some definition or concept of a thing we want to measure. We define it, we try to operationalize that by converting the definition into a procedure we can use to generate a number. So then at the end of the day, we want to know, is this a valid measure? Well, is that procedure for generating a number capturing everything that was in the definition, or is it missing certain things, right? When we think about reliability, one way of doing it is test-retest reliability. So the question there is, would you get the same value if you did this again, right? So that you could think of it like when you step on a scale and you get one number, you step right off and then you step right back on, it should give you the same number again, right? Like that number shouldn't have changed. So if it is giving you different numbers each time you get on and off, that's an unreliable scale, right? Internal reliability is for a measure that has multiple indicators, like the ones we were looking at before. You know, if there are 7 statements that are meant to assess anxiety, well, those should all be correlated, right? If they're all really manifestations of one thing, that underlying mental state of anxiety is giving rise to all 7 of these observable indicators, well, they should all be very strongly correlated with each other, right? So if they're not all interrelated, then that's a problem for the internal reliability of the measure. And oftentimes that's assessed with coefficient alpha and omega. If you see those terms, that's a measure of reliability. Now, thinking about these things, one thing you might start to notice is it really seems pretty clear that if you want to do any of this, you need a pretty clear background theory. Right. So in order to assess face validity, you have to have a good intuitive sense of what is this thing that you're trying to measure anyway. So you have to have it pretty clearly defined. Construct validity literally says, do the theoretically predicted relationships emerge if you actually use this measure? Right. So if this thing were measuring the thing it's supposed to measure, what would its relationships look like with other variables? Well, you need to have that theory that tells you what those relationships are in order to do any of that. Same with content validity. What is the definition? Is this measure capturing everything in that definition or not? Test-retest reliability. Well, some things should be reliable over time, i.e. the same, but some things shouldn't, right? So if you have a personality trait, maybe that's the sort of thing where it's defined as something that is pretty stable, doesn't change much over time. So if I give you this measure today and I give it to you in a week, you should get the same score. It's not the sort of thing that varies from week to week. But what about something like mood? Well, clearly that is going to vary from week to week. So in order to know whether or not test-retest reliability is even a relevant criterion, you need to have a clear enough definition of the thing you're trying to measure to say whether or not it's the sort of thing that should be stable over certain intervals of time or not, right? So all of this is just to say validity and reliability of measurement relies very heavily on having a theory in the background that can enable you to make these kinds of tests. While we're talking about validity, it's important to differentiate between 2 different ways in which that term is sometimes used. So thus far, we've been talking about the validity of a measure, which is to say, is the measure measuring the thing it's supposed to? But sometimes people often talk about the validity of a study, or I actually think it's better to think of it as the validity of the inferences that you're drawing from a study. Some of those inferences will be internal to the study. So it'll be what happened in this study? What is going on here? What does this study show about what's happening in this specific context? But then some of the inferences will be beyond the context of the study, right? So we've ran a study, we found something, now we're going to try and generalize. And to what extent are those generalizing inferences valid? When we talk about internal validity, another way of thinking about it is the degree to which the study justifies conclusions about the relationships between variables, or do the data actually support the researcher's claims about what happened, right? So, for instance, if we administer some kind of experimental intervention and we see a change in some outcome, we're probably going to, make the inference that the intervention has an effect on the outcome. But is that actually a valid inference, right? Are there alternative explanations that haven't been ruled out that could just as well make sense of the change we saw in the outcome? That's the kind of thing we're doing. External validity is about the degree to which the study justifies conclusions beyond the study. Can we generalize? Do the data from this study support claims about what happens out in other settings, or the real world, so to speak, right? It's about generalizing from the study to other contexts. There are many different kinds of threats to the validity of a study, and they come in different kinds, reflecting the internal and external distinction that we've just mentioned. Obviously, I won't cover all of them, but just to give you some examples, internal validity can be threatened by confounds. So the classic correlation does not equal causation. That's where X and Y are correlated. That could mean Y causes X. It could mean X causes Y. It could mean Z, some third thing, causes both X and Y. And that gives a correlation between the two, even if there's no causal relationship. Z, that third thing, is a confound. It's that alternative explanation that hasn't been ruled out. Non-random assignment to group or condition is another potential threat to internal validity. So imagine you wanted to understand the effect of going to college on, say, job satisfaction down the road. Well, you could try just comparing people who went to college and who didn't go to college in terms of job satisfaction, but there might be things that led people to go to college that also in turn influence their job satisfaction down the road that have nothing to do with going to college. That would be a threat to the internal validity if you wanted to say going to college has such and such an effect on job satisfaction. Failed manipulations are also threats to internal validity. Maybe you try to experimentally manipulate something, but you just fail. You just don't do anything to that thing you're trying to manipulate, and then you say, hey, there was no effect on this outcome. Well, calendar effects are where something just happens, like, hey, a pandemic hits, and that affects the outcomes you were measuring, but it has nothing to do with what was going on in the study. It's just this other thing outside of the study that's intervening on and affecting the things you're measuring. Instrumentation effects are where the act of measuring something can actually change the thing that's being measured. So imagine you're in a study, and every single day you get these questions about how you're feeling. And every day you're thinking about your emotions. That might influence your emotions over time. You might start thinking about how you're feeling and why, and then you start doing things to change your emotions, and next thing you know, the measurement of your emotions has influenced those very emotions themselves. External validity can be threatened by non-representative samples. So actually a lot of psychological research is conducted on undergraduates, students at college. Can we generalize findings that really do emerge? Like if we got great internal validity on these studies, but the studies all have undergraduate students as the participants, can we really generalize from that to, say, US adults in general, or people, humans in general? Not exactly clear. Unusual circumstances are another potential threat. So thinking, back in the pandemic example again, maybe you find something during the pandemic and the internal validity on that study is rock solid. It really is the case that, there is this relationship, but only during the pandemic. Maybe it's not generalizable beyond that particular and very unusual circumstance. Artificial or specific stimuli are another potential threat. So if you're doing something in the lab and you're trying to manipulate something and you're just using these really kind of artificial ways of doing that don't reflect the way it really works, in the real world. For example, sometimes people will study aggression using hot sauce measurement. It's like, how much hot sauce are you going to put in this person's drink? And like, that's the measure of aggression. You might think that's just this weird artificial thing that like, the ethics board at your university will allow you to do this, but like, it's not really what aggression really looks like out in the real world. That would be a threat to the external validity or generalizability of findings from a study. There's one final idea that I want to introduce before wrapping up, and that has to do with a distinction between two different kinds of research questions or hypotheses that psychologists can ask. So some hypotheses are about differences between people. Other hypotheses are about differences between points in time within a given person's life, right? So a between person hypothesis might be something like extroverts are happier than introverts. A within person hypothesis might be that when a person spends more time socializing, they will tend to be happier, right? So the idea here is it's not that there are just some people who socialize more than others and those people are happier than people who socialize less. Rather, the idea is that when a given person has a change in their level of social interaction, that's going to come with a corresponding change in their level of happiness. This distinction between within person and between person hypotheses comes with some really fundamental implications for the kinds of research designs that we can use to test those hypotheses. A between person hypothesis can be tested at a given moment in time. If you do a correlational study, you just gather a sample of people, you assess some things at one point in time, and then you can look for relationships, say between extroversion and happiness. Or if it's an experimental design, you could randomly assign people to two different groups, you administer some kind of intervention, and then you just test for a difference at that point in time. That's a between-person design. A within-person design, on the other hand, requires that you have repeated observations for the same people over time, right? Because you want to be able to compare, at one time versus another time, you need multiple observations from the very same person in order to make those kinds of comparisons. So you need to have this kind of design where you have, it's called a longitudinal design, where you repeatedly assess things over an extended period. I really like this image as a way of illustrating why this distinction matters. This is a reference to Simpson's paradox, which is named not after the TV show, but a statistician. But the paradox is that you can have opposite relationships between variables at different levels of analysis, right? So it's not truly a paradox, but the apparent paradox is if you, at any individual level, in this case, any member of the Simpsons family, if you look at the relationship between these two variables, it's negative. But if you ignore that and you look at differences between people, then the relationship is positive, right? So, maybe in this case, it's typing speed and typing accuracy, where for any given individual, if you make them type faster and faster, their accuracy will go down. But there are just some people who are way better typers than others. So Marge is just faster and more accurate than Homer, even though she too, within persons, shows this negative relationship. There's that between person positive relationship. Another example I really like of this is body mass and longevity. So apparently, if you look at between species comparisons, then larger animals live longer. So, giraffes live longer than mice. But if you look within species, it's actually the smaller animals that live longer. Smaller mice live longer than larger mice, and smaller giraffes live longer than larger giraffes. Even though there's this positive between species relationship, there's a negative within species relationship. So again, the relationship between variables depends on the level of analysis that you're talking about. And so in psychology, within person and between person, you can get different results. And it's very important to be able to make that distinction and to design a study that will allow you to test the hypothesis that you're actually interested in. We covered a lot of stuff today. So let me just summarize the key ideas again quickly for you. Measurement we talked about as the principled application of numbers to phenomena. In psychology, those will be mental phenomena, which we often refer to as constructs. A construct is something that we assume we cannot directly observe, but that we can make inferences about on the basis of things that we do observe. A measure is valid to the degree that it measures the thing that it's supposed to, and reliable to the degree that it does so consistently. These are two dimensions along which measures can vary in terms of their goodness. Relationships between variables can be moderated or mediated. Dependent variables are ones that depend on some independent variable or set of variables, but that relationship can itself depend on some third thing, a moderator, and it can also operate through some independent or indirect process, a mechanism or something that we call a mediator. Inferences that we draw from a study can be internally valid when we're thinking about the context of the study itself, what actually happened in the study. Internally valid inferences are ones that are justified by the design of the study and the data that were collected. Externally valid inferences are ones that we draw from the study to a larger context or to the world at large. Finally, when we test hypotheses, some of our hypotheses are about differences between people, and some of them are about things that happen within people's lives over time. And these two different kinds of hypotheses demand very different kinds of study designs. That's it for now, folks. Thanks so much for listening. I hope you got something out of it. We covered a lot of stuff and at a pretty abstract level. So if you're interested in applying some of these ideas in a more concrete and grounded way, we've put together a package of materials to help you to do that, including some actual papers from psychology journals where you can think through these questions of validity and measurement in the context of an actual research question that people are currently working on. So feel free to take a look at those, and otherwise, I will see you later.